Welcome back to Further Solutions Academy. Further Solutions Academy. On this video, I'll be walking you through on Frobenius Method, which is Frobenius is a part of method of solving power series. By the end of this video, you understand this method very well, I think, by God's grace. And before I go deep to that area, I think I must to show you some condition. There are many methods in power series. I mean, of solving ODE. We have legendary, we have Bessel, we have. Let me try to put them in a rating, right? Please, okay, take note of this very well. And don't forget, Frobenius method is always like this. And y prime plus p of x y prime and plus q of x y equals to 0. Please take note of this. That is what we are talking about on the Frobenius. I can reduce this and reduce the, Now, when you talk about legendary, this is how legendary looks like. Please take note of this. These are called important ODE in physical engineering. Please take it of that very, very well. Now, all these things you have to work on it at least if time permits us. It will be allowed on this video anyway. And the next video will be legendary. We have a legendary polynomial and so on and so forth. You will surely understand this very well. Just stay with us. I think you'll be fine with us. Now, but on this video, I'll be on Frobenius method. We call it initial equation or this initial form of a power series. That is what we are to work on this video. Now, let me try to put examples so that you will really understand. In the previous video, I've explained what is called ordinary point and singular point. And from the singular point, I said that we have singular point, we have ordinary point. Now, from this singular point, I can say that what? Regular singular point and irregular singular point. Please take note of this. I've told you I was on it in the last video, which I explained the condition, how to generate this, because they are so important to this on the board, which is very, very important. Okay, now let me do on my Frobenius. Now let's work on Frobenius method. Frobenius method is a very nice one. Let's see how it will go. I have this problem to explain Frobenius method. Okay, now let's start the work. Let's see how we are to move. Okay, now when we have something like this, don't forget the singular point. Singular point will be equals to what is 0. Please take note of that because of what this is x. Does it have a regular singular point? No. I think it has a singular point and regular. Now, please take note of those things we need to work on. Now, the first thing I will do, solution to this problem. Now, I will let my what y equals to of this, which is n to 0 and to infinity, and this is going to be a of n Sn minus plus 1. Now, can you see the difference between this and the last one we did? That is what we're going to do. Now, in this part, I'll be having my y prime. It will be what? Of n to 0, infinity. I have my what? N plus x. We have what? X raised to power n plus minus 1. Now, I have my prime equals to 0 now. A of n plus and n plus minus 1 and x raised to power n plus minus 2. Now, that is what we need to do. Now, since I've done that, I will now come back to the given equation, which is 2x y prime plus what? 1 plus x y prime minus 2y equals to 0. Now, I will now substitute the prime and the prime on the real equation, which I will be having 2 in the bracket of summand of n to 0 to, from 0 to infinity of my prime is what? I can say that n plus c, n plus minus 1, and the a of n, s raised to power n plus c minus 2, and plus, that is the first step. The second one, I'll be having 1 plus x bracket, my y prime is n plus c, which, sorry, I have my summand. My summand run from 0, this is called counter, which is going to be n plus c bracket of a of n x n plus c minus 1. And I will move on to that. I think I don't want us to. Let me just continue like this. Plus, the last part of it will be, I think I'll be having 2, which is going to be minus 2, and my y, it will be counter run from 0 to infinity of y. My y, it will be a of n x n plus c will be equals to 0. Now, that is what we are to do. Please take note of it. It's good to put this way. I think that is how to solve mathematics. Now, we can see that we are taking a very good step, which from here, we need to do some computation. You must know how to compute here. Since I have this, I will now move on by having, I think I need to have bracket. This is my x, this is x, and this is another x, this is another x. Now, it means I can say that, 2 of counter of n plus 1, don't forget it runs from 0 to infinity, and plus c minus 1. I have my what? A of n x n plus c minus 1, because this prime 1 has taken away 1 here, which is going to be minus 1, and plus this one will be having counter, it runs from 0 to infinity, and I'll be having n plus c, and a of n x n plus c minus 1, which is for this, and plus I'll be having it also counter of running from this to this, which I'll be having s plus c, and which is, it will be ax raised to power n plus c, which plus minus, this will be 2 of counter of this to 0, and I have this will be equals to an sn plus c. Now you can see equals to 0. I think it's good to put this way. Now you can see that this and this are the same, and this and this are the same. It means they can be in a one bracket. Sorry, they can be in a one bracket. Please permit me to manage the board this way because of space. This is not necessary. This is not necessary. Okay. Now, with this, I can now continue by what next I need to do now. I think I can generate this and this to be in one counter, which I will be having a counter of n to 0 to infinity. I'll be having two bracket of n plus c plus minus 1, which is I'll be having plus, and next one will be equals to, also I'll be having n plus c, which is all in bracket of a n and s n plus minus 1. Take note of that. I just pack this and this into one counter, and we move on plus. The next one will be I have this and this in one counter. It will be a what? A summer run from n to infinity, which is I'll be having I have this, which is I'll be having n plus c, and minus 2. Yes, minus 2, close the bracket, a of n x n plus c equals to 0. Now with this, I think I'm very good to go. I think I've done a very nice job. I think. Is there any problem? No, there's no any problem. Now, since I have that, I can now say that now with what I've done, let me try to shift this. Let's see what will happen. I think let me just say that what my n will be equal to 0 on the first counter. My n equals to what? 0 on the first counter. It means if my n equals to 0, I think I'll be having 2 bracket of c bracket of n minus 1 plus c close to bracket a of 0, and we have what? We have x raised to power c minus 1 plus, it means I've successfully shifted this one now. It will now be what? It will run from what? N to 1 to infinity. Please take note of this. It has been shifted by having my n equals to 0, which I will be having 2 bracket of n plus 1, n plus c minus 1 plus n plus c. We have my an and this will become x n plus c minus 1. Now this will now be what? Plus this also. You don't need to shift anything. I will leave it the way it is, which I'll be having counter run from a 0 of this, which I'll be having n plus c minus 2 bracket of a of n sn plus c equals to 0. Now I think I'm good to go. Yes, I'm good to go. The only problem is this and this, there is a problem, and this are not the same. Now the only thing I can do now is that, hope I'm not making any mistake. No. Now that is very, very good. Now with this, I can generate my what? Indicial equation. My indicial equation will be equals to this will be this bracket belongs to this, which I'll be having 2c squared. Now I'll be having, hope I'm not making any mistake. Oh no. Okay. There c, yes, sorry, there is 2c, yes. 2c squared plus 2. Now it means I'll be having 2c squared plus 2c equals to 0, which I'll be having, which also implies 2c squared yes, minus 2. This is minus 2. Now, which is going to be minus c equals to 0. It means I will be talking about my c bracket of 2c minus 1 equals to 0. It means my c equals to 0 or c equals to 1 all over 2. Please take note of that. I think I've done my initial equation. Now, the next thing I need to do now is that I will shift the second series. Shift the index of second series. Now, how do I shift my index of second series? Now, whatever you just see there, you put your n equals to what? My n will be equals to n minus 1. Take note of that. That is my second That is what I will do for my second. This is my second this thing. It means it will be equals to, it means I'll be having yes, if I'm to shift that, it means I'll be having a summand of what? To 1, infinity, which I'll be having, hope I'm not making any mistake, no, a of n, bracket of 2n, bracket of c, bracket of n plus c minus 1, and plus n plus c, close the brackets, which is, it will be s n plus c minus 1. Sn plus c. Don't forget, this is not having any problem, and it will be plus, this one will be equals to, it will be plus, now summand of what? To 1 to infinity, which I'll be having a of n. I've told you that in the second summand, this equals to n. Now it means my n equals to, that is my n, and this one will be equals to my n minus what? I'll be having, okay, I'll be having that, which I'll be having, okay, now it will be equals to bracket of n plus c minus 3, and this one will be x n plus c minus 1. Sn plus c minus 1. That is what we are talking about, which is, it will be equals to what? To be equals to 0. Now, since I have this, I cannot continue. The next thing I need to do now is that, okay, now before I get my correct solution, I think this and this are the same power form now, which is the counter are also the same. The counter are also the same. It means I can say that, look at this, I can turn this to what? The summand of n to 1 to infinity, because it will cover everything. My a of n, take note of that. This one and this one, there are two common. I want to factorize this thing. This one is to be n plus 1 is the factor, which is I'll be having 2 will be here. 2 will be here, bracket over. It means it will be indirectly, I'll be having, if I bring out this, it will be 1. 1, it will be what? N plus 1 squared. Please take note of that. N plus 1 squared, and that is very correct. This n plus 1, yes, and bracket of n plus n, bracket of that, which is going to be, there are 2 here, 2 will be here, 2 will be here. Let me do mistake. I think I'm making a mistake from here. Let me try to do something very good for better understanding. Okay, can you see mathematics is very nice? See the way the guy is sweating. I think it's nice to do that. Now, with what is on ground, let me first pack them together before talking about anything, because to avoid silly mistake, I have to be very careful, because any mistake I make here is to scatter it will affect my my counter at the end of the something. Now, bracket of n plus c minus 1 plus n plus c, I think, yes, plus this will be this is for this. Please take note of this. This is for this, and I'll be having we have n plus c minus 3. I have n minus 1. Now, this is for that. Everything will be covered with plus c minus 1 equals to 0. Please take note of that. I think from here, I can now continue by saying that if I factor out 2 of this, now if I factor out 2 of this, take note of the n, it's run from 1. The counter start from 1 to infinity now. Now, it will be, I factor out this. It means if I factor out that, it will be this and this, this and this. I have what? N plus c. If I have my n plus 3, what's left here, it will be what? 2 bracket of n plus c minus 1 plus 1. Please take note of that. That's what I'm trying to do that time. Since I have that plus, this one will be n plus c minus 3 bracket of, I can't do anything to this because of the n. This is a of n. Please take note of that. Now, also move on to this, which is my x n plus c minus 1 equals to 0. Now, what can I do? I think this one will be what? 1, 1, which I'll be having 2, 2, 2, which I'll be having summary run from 1 to infinity. I have 2 n plus c bracket of squared. This and this, 1 minus this becomes 0, and then this one becomes squared. 2 of them become squared. Since I have that, I think I'm working smartly now. Okay. Okay, now. Yes. Okay. Okay. Now, since I have that, I can now continue by having, okay, now, this one will be n minus n plus c, which is, I'll be having minus n plus c of an plus n plus c minus 3 of an minus 1, which is bracket of equals to what? 0. Now, at this point, I can now say that what? This will be equals to 0. This 2 will be equals, x raised to power n plus c minus 1 equals to what? Is 0. Now, since I have that, I can now say that what? My a of n, can I say that what? My a of n, bracket of what? A of n plus c, and n to n plus 2c minus 1 plus n plus c minus 3 of an minus 1, it will be equals to what? 0. Now, from here, I can now get my what's the current solution, which I'll be having my a of n will be equals to minus n plus c 3 brackets of an minus 1 divided by n plus c and 2n plus c minus 1, which is my that. Don't forget, my counter must show here, because there is no more counter here. My n must be greater than equals to 1. My n must be greater than equals to what? 1. Please take note of that. Please, if you are not putting this, it will make your work to be not to be having meaning. Now, that is very, very important at that point. Now, permit me to rub the question and you see mathematics is more interesting here. That is maths for you. Okay, for those that want to come and study mathematics, I think it's very good. Engineering students, they are good to go. And advanced math, but majorly this series is for advanced mathematics, not advanced, very advanced. And I think with this, I can now continue by having, now I've had my recurrence solution. Now for c equals to 0, I've established that thing, my c equals to 0. It means anywhere I see c, it means I'll be having a of n equals to, I'll be having n minus 3, bracket of a of n minus 1 divided by n bracket of 2n minus 1, which is, that is what it will be talking about. Now, I will notice that when my a equals to 1, my a equals to 1, because the counter is what? N greater than equals to 1. It means I must start counting from 1. 1, 2, not 0 this time around, or minus 1. Now, when my n equals to 1, it means I'll be having, wherever you see n, put 1 in it. It means it will imply a of what? 1, it will be equals to minus 3. Minus 2, sorry. Minus 2, and a of what? minus 1, which I will be, no, to be a naught, sorry, a naught divided by, this will be 1, 1, that will be 1.1, that is 1.1. Okay, now of a naught. Now when my n equals to 2, my n equals to 2, it means my n equals to 2. That is what I'm trying to say. Here my n equals to 1, here my n equals to 2. Since my n equals to 2, it will be a of 2, it will be equals to minus 1, because there is a minus here, and I have minus 2. Yes. I mean, minus 1. Yes, because of this is 3. If I put 2 here, 2 minus, that will be 1. 2, that will be 1. Sorry, it will be 1. Sorry about that. I'll be having what? I have 2 here, I'll be having a1 divided by, this is going to be 2. 2, that will be 4, that will be 3. That will be 2.3, which I'll be equals to 2.2.3 of what? Of a naught. Of a naught. That's what I'm talking about. Normally, this we cancel this, which also implies 1 over 3. Normally, when you are doing sequence, I mean series like this, don't be simplifying. It's not good. It's not good for you to avoid silly mistake. When my n equals to 3, my n equals to 3 here. Now it will be what? Minus 1 bracket of 3. It will become 0, and a of what? 3 minus the, that will be 2, which I'll be having 3.3. Now it means for n greater than equals to 3, my a of 3 will be equals to a of 4. That is what is all about. Now since I have that, I tell you why not will be equals to what? A naught plus 2a naught plus a naught all over 3 of what? S squared. This is one s. Okay. Yeah. Now y naught equals to what? Equals to 1 plus 2x plus 1 all over 3 s squared. Everything into bracket of what? A naught into counter. I think this is a counter. Now, since I have that, now assume that what? Let me use assume that a naught equals to 1. Since if my a naught equals to 1, it means a1 it will be equals to 1 plus 2x plus 1 all over 3x squared, and so on and so forth. Now that is what we need to do there. Now since I move on to that level, I think I need to direct the second option. This is my second option, is that it's telling us where my c equals to what? Where is that? I need that place. Okay. Now we have done this. Now remain this now. When my c equals to what? Now, don't forget that I can now say that I can say this, that my b of n equals to, because I'm talking about a of n. Now b of n will be equals to b of n will be equals to n minus, bracket of n plus c minus 3 bracket of a n minus 1 divided by, I have my a plus c 2n plus 2c plus 2c, this is 2c, plus minus 1 bracket of b of, let me use b of n to avoid silly mistake. Now my c is equals to what? My c equals to 1 over 2. It means my b of n will be equals to 1 over 2 of this. It means I'll be having minus 1 all over 2 bracket of 2n minus 5. We have what? bn minus 1. Okay, I need to rub this. This will not be able to rub it very well. Okay. Okay, now let me be very fast. Now I'll have my b of n. I think b of n will be divided by, I'll be having 2n bracket of 2c plus what? Minus 1. Is it plus 1? Plus 1. Plus 1. Okay, bang, 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 bang. That is minus. It will be minus 1. Okay, plus 1. Now, it means I'll be having b of n equals to minus 2c minus 5 bracket of b of n minus 1 divided by 2 of n bracket of 2n plus 1. Now, it means my b1 will be equals to minus 1 minus 3. Yes, minus 3 divided by that'll be 2.3 of b1 of b minus b of 1, b naught, b naught. B of 2 will be equals to minus 1 and b2, which is going to be b1 divided by 4.5. Now my b3 will be equals to minus 1 minus 1. b3 will be equals to this. That'll be 6. That'll be 1 bracket of b of what? 2 divided by what? 6.7. Now it means my b of n will be equals to minus 2 of n 5, b of n minus 1 divided by what? 2n bracket of 2n plus 1. Now it means indirectly I'll be having my b of naught, which is going to be plus b1 of x plus b2 of x squared plus b3 s3 and so on and so forth. Now since I have that, it means I can now say that everything carry b naught. If I have to move with b naught, it means I'll be having my b of a naught minus bracket of 3 of 2.3 of b naught of x plus minus 1 minus 2, minus 3 of what? B naught of x squared divided by 2.3.4.5 and plus